Hello everyone, myself Nishitha, Assistant Professor, Department of CSIT, working at MLR Institute of Technology. In previous sessions, we have seen about input-output hardware and input-output applications interface. So, in this session, we are going to see about kernel input-output subsystem. So, how the kernel is performed by this input-output subsystem. So, let us see the overview of this presentation. We are going to see about kernel input-output subsystem. So, kernel input-output subsystem is nothing but it provides many services related to input-output. So, it provides n number of services which are connected through some input-output subsystems. Several services such as scheduling, caching, spooling, device reservation and error handling. These all are provided by kernel's input-output subsystem built on the hardware and device drive infrastructure. So, this kernel is providing some services to the input output. So, there are n number of services which can provide by the kernel. Kernel is nothing but the subpart of the operating system. Without kernel, the operating system doesn't work. So, it is a core of the operating system that can be provided some services to input output devices. So, this kernel is providing some operations to perform for this input output devices. So, first one is input output scheduling. To schedule a set of input output requests means to determine a good in order which to execute them. So, you are going to schedule some input output operations that are performed and executed in good order. Each and every device will be performed, executed well. The order in which the application issues the system call, it is the best choice. So, the order in which the application issues the system call. So, you are raising some system call that gives as a best choice. Scheduling can improve the overall performance of the system. So, it can improve its performance by accessing this method. Can share device access permissions fairly. So, it can access the permissions fairly to all the processes and reduce the average waiting time, response time and turnaround time for input output complete. So, in the previous session in process scheduling algorithms, we have seen about waiting time, response time and turnaround time. So, whatever this scheduling of each and every algorithm, we are going to solve the each and every scheduling algorithm, either it is a FCFS, priority or round robin. So, based on the scheduling, we have solved the n number of different processes based on the average time, average waiting time, response time, turnaround time and input output complete. So, how the input output operations is completed, at what time the execution has been done. So, based on this all, we have calculated the input output scheduling algorithms. So, next one is buffering. What do you mean by buffering? Buffering means loading and erroring occurs. A buffer is a memory area that stores data being transferred between two devices or between a device and an application. Here, a buffer is more memory area. It is occurring some large amount of memory and that stores the data which is transferring from devices to other applications. So, here the devices are between a device and different kinds of applications you are transferring the data. Buffering is done for three reasons. So, there is a reasons for this buffering. So, it consists of three reasons for this buffering. The first is to cope with the speed mismatch between the producer and consumer of a data stream. So, here this buffering is happening between the producer and consumer of data stream. And the next one is used to buffering provide adaptation for data that have different data transfer size. So, it is having some different sizes of each kind of data, either it is a megabytes, gigabytes or MBs. The third use of buffering is to support copy semantics for the application of input output, that is nothing but copy semantic. So, first one is it is based on producer consumer data stream and the second is based on the data transfer sizes, either it is megabytes, gigabytes or any other bytes. So third one is, it is based on the copy of semantics of each application, that is nothing but copy semantics. Next one is caching. A cache is a region of fast memory that holds copy of data. Caching is nothing but, it is the fastest memory. It is nothing but holding some copy of each data. Access to the cached copy is much easier than the original file. So it accessing the cached copy and easier to copy its original file. For instance, the instruction of the currently running process is to store on the disk. So whatever the instructions provided by the system that are currently running by each process and that are kept under disk. Cached in physical memory. Cache is kept under physical memory and copied again to the CPU's secondary and primary caches. So it is again copied from the CPU and kept in the secondary and primary cache memories. That is what about caching. Next, spooling and device reservation. Spooling is nothing but, a spool is a buffer that holds the output of a device. It is holding some output of a device, such as printer that cannot accept interleaved data streams. So here the printer cannot accept all the interleaved data streams. Whatever it can accept, only it gives the print. Although a printer can serve only one job at a time. Yes, one paper, after the giving one document only, it can accept next document. Until and unless the document of the first file is getting print, then only it goes to the next. All the files cannot get at a time of the print. Several applications may wish to print their output concurrently. So several applications can be print concurrently without having their output mixes together. So without any output of that, they cannot mixes together. The operating system solves this problem by preventing all output from continuing through the printer. So this problem preserves some all output operations and that are continued to the printer. This is what about spooling and device reservation. So next, error handling. An operating system that uses protected memory can guard against many kinds of hardware. So it can guard against many kinds of hardware and application errors so that it completes system failures. So the application errors can be controlled by the system failures. It is not only the usual result of each minor mechanical glitch. Devices and input-output transfers can fail in many ways. So whatever the errors are handled by this operating system, they may get failure sometimes by using this mechanical glitch devices, and other input-output transfers can also get failure in any number of ways. Either for transition reasons, as when a network becomes overloaded, or for permanent reasons, as when a disk controller becomes defective. So whatever you are sending or receiving the data, when it is overloaded, the data cannot share, then the errors may be occurred. So who can handle this error? Until and unless you are performing some operations on operating system, then only it can perform or resolve that solution. So this is how the error handling occurs in the input-output subsystem. Next, input-output protection. How the input-output protection can be done? Errors and the issue of protection are closely related. Errors and issues are nothing but they are protected and they are closely related. A user process may attempt to issue illegal input-output instruction to disrupt the normal function of a system. So whatever the errors which are handled, and these are used by the illegal input-output instruction and they disrupt the normal functions of a system. We can use the various mechanisms to ensure that such disruption cannot take place in the system. So whatever the mechanisms that are ensured by this disruption, they cannot place in the one system. To prevent illegal input-output access, we define all the input-output instructions to be privileged instructions. To prevent illegal input-output access, we define all input-output instructions to be privileged instructions. So, whatever the input-output access which we are giving that are defined to the input-output instruction that are privileged by the instruction. The user cannot issue input-output instruction directly. So, until and unless the input-output operations performed basically, they cannot interact directly. So, here some issues raises. That is how you are going to protect some input-output protection. So, protecting the data safely and keeping some encrypted keys. That is protecting the input-output protection. So, what are the advantages of kernel input-output system? So, there are 3 advantages: device independent, efficient resource management, and concurrency management. So, what do we mean by device independence? Here, the kernel input-output subsystem provides device independence to the user applications. So, here it is providing some device independent to some users applications. It abstracts the hardware details and provides a unified interface to the devices. It is providing some hardware details and providing some unified interface for each device. This means that the application developers can write code that in an independent hardware platform. And the kernel input-output subsystem takes care of the hardware specific details. So, whatever you are giving the data, that can be shared independently. So, how this data is transferred, it may be writing the code independently on the hardware platform, or the kernel input-output subsystem taking care of each and every hardware specifically. So, that is how the devices are getting independent accessible. Efficient resource management. The kernel input-output system provides an efficient resource management for the input-output devices. It is providing some efficient resource management for each and every input-output devices. It manages the input-output requests and schedules them in a way that optimize the usage of available resources. So, whatever the available resources are available, that can be easily managed by these input-output devices. This ensures that the input-output devices are not overutilized and the system remains responsive. So, whatever the input-output devices that are not overutilized, so whenever it is not overly utilized, then the response will remains unresponsive. If it is regularly utilized, it gives responsiveness. Next, concurrency management. The kernel input-output subsystem manages the concurrency issues that arise when multiple applications try to access the same device simultaneously. So, whatever the kernel which is going to manage these concurrency issues, that can handle multiple type of applications and they can easily accessible, each and every device works simultaneously. It ensures that the applications get exclusive access to the device when needed and allows multiple access to share each and every device in an appropriate manner. It can easily share or allows multiple applications. Each and every device can easily shareable in an appropriate manner. That is what concurrence management. So next, what are the disadvantages of this kernel input-output system? So there are two types of disadvantages of this kernel input-output subsystem, that is complex implementation and security risk. So what do you mean by complex implementation? The kernel input-output subsystem is a complex software component that requires a lot of resources to implement and maintain. So you are going to implement some complex responsibilities in the kernel. The software exists or doesn't exist. So it may raise some lot of resources. So that is how you are going to implement and how you are going to maintain. If any issues raises when the kernel input-output subsystem, can affect the performance and stability of the entire system. So here, if an issue raises, it can affect by this performance and stability of the entire system may be hacked. That is what of the irresponsiveness of this complex implementation. This is one of the disadvantages of input-output subsystem. Next, security risk. The kernel input-output subsystem can pose security risk to the system if not implemented correctly. So, if you are not implemented correctly, it gives some security risk. Attackers can exploit vulnerabilities in the kernel input-output subsystem to gain unauthorized access to the system or cause a denial of service attack. So, in this disadvantage, this is an exploit vulnerabilities of each and every kernel input-output subsystem, and they are gaining by the unauthorized access, and the system is causing some denial of service attacks. So, this is getting some security risk. So, they are spoiling the data, and the access are given to unauthorized. They are easily accessing the data for the unauthorized users. This is a very disadvantage of one of the security risk for this input-output subsystem in the kernel. So, what are the typical functions and services affected by this kernel? That is process management, process communication, memory management, input-output management, file management, security and protection, and network management. So, what do you mean by process management? Here, it can save context of the interrupt program and dispatch a process, manipulates scheduling list. So, here it is saving the context of each and every interrupted program and dispatching a process and manipulating schedule lists. Next, how we are going to communicate with the process? Sending and receiving through inter-process messages, means sending and receiving. Memory management, set memory protection information, that is swap in, swap out, handle page faults. So, page faults may be occurred. Input management, initiating input-output, process input-output completion interrupt, recover from input-output errors. So, these are initiating, completing and recovering. File, opening, read, write data. Security and protection, add authentication information for a new user, maintain information for protecting the files. So, you are giving an access to the new users and maintaining the information safe. Network management, sending and receiving data through a message. This is what different functions and services provided by this kernel. So, in this session, we have seen about kernel input-output subsystem. What are the advantages of kernel input-output subsystem and disadvantages of kernel input-output subsystem, and what are the functions of kernel and what are the services of kernel we have seen in this session. So, if you have any doubts, you can comment in comment box. Thank you.